Everyone, this is Michael, the Rohini College of Engineering and Technology, Palkulam, Kanyakumari. So today we are seeing up the topic is the ventilation. So first was the introduction of ventilation. So the Webster Dictionary defines the ventilation simply as circulation of air. The ventilation does not necessarily mean the use of mechanical devices such as fans being employed. Non-fans or natural ventilation is still considered to be ventilation. From the simple definition of ventilation, we move forward the ventilation of tunnels. The use of tunnels dates back to this early civilization. So too does ventilation is the form of the natural ventilations. The use of the term tunnel in this chapter refers to all transportation facilities rated, including road tunnels, transit, then metro, underground and subway tunnels, and railway tunnels also. So road tunnels from the ventilation viewpoint are defined as any enclosure through which road vehicles travels. Early ventilation concepts. The earliest advanced evidence of the serious consideration of the ventilation appeared in the transit tunnels, where the ventilation of transit tunnels were accomplished by utilizing the piston effect generated by the moving trains and by constructing the large grating covered openings in the surface, sometimes called blowholes, thus permitting the continuous exchange of air with the outside of the subsequent lowering the tunnel air temperature. So one of the first normal ventilation systems in a road tunnel was in the Holland Tunnel. So New Jersey, New York in the 1920s. As a part of the planning and the design process of the Holland Tunnel, a series of innovative tests were conducted by the US Bureau of Mines. The Holland Tunnel opened to the traffic in 1927. Types of ventilation. There are two basic types of ventilations airflow systems used in the transport tunnels. The one is the longitudinal and the transverse. The longitudinal systems or air moves longitudinally through the tunnel, while in the transverse systems the air moves both transversely and longitudinally depending on the type of transfer system employed. In longitudinal ventilation, the airflow is longitudinal through the tunnel and essentially moves the pollutants or heated gases along with the incoming fresh air and provides the fresh air at the beginning of the tunnel or tunnel sections and the discharged heated or polluted air at the tunnel portal or the end of the tunnel section. Then the longitudinal ventilations can be configured at the either portal to the portal or shaft or the shaft to shaft as shown in figure. The air entering the tunnel is ambient conditions and is impacted by the pollutions, contaminants and the heated gases from the vehicle moving through the tunnel. As clearly seen in the figure, it is a longitudinal airflow that is applied most often in the transit and railway tunnels as the moving trains themselves create longitudinal airflow via what is known as the piston effect. The transverse ventilation, the transverse flow is created by the uniform distribution of fresh air and the uniform collection of the radiated air along the length of the tunnel. The airflow format is usually moves in the road tunnels, although it is occasionally used for unique circumferences. These uniform distributions and collection of air throughout the length of the tunnel will provide a consistent level of the temperature and pollutants through the tunnel. The transverse ventilation systems can be configured as the fully transverse or semi-transverse. This is the portal to portal, this is the interportal and the exiting portal. Thank you.